If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where we are building concepts from sequence and series. Today we will be familiar with the summation symbol, that is big sigma. We will see what is the meaning of this sigma and some properties of this one. Okay, then let's see this. Okay, let's get familiarized with the summation symbol. This sigma symbol, you will come across it many a times. So let's see what is this. So if you see this AP 1 plus 4 plus 7 arithmetic series, suppose I have written. So what is its nth term? Its nth term is a plus n minus 1 into d. D is here 3. You can see the difference is 3 here. So its nth term is tn minus 2. So this is the rule actually which is following it. You put n, you will get all these values. 1 if you put, you will get this. If you put 2, then you will get this. If you put 3, then you will get this. If you put 4, then you will get this. As your n changes, continuously 1 numbers will come on that series. Now suppose someone asks you to take S20, summation up to 20 terms of this series. So what you will add, you will write all this and you will add for first 20 terms. Up to that is 58. This is the 20th term. If you put 20, you will get it. It is 60 minus 2, 58. Now the same thing S20, without writing it in a long series, we can write it in this symbol also, using this symbol. This you can see, this is a variable I have introduced, new variable k, which is running from 1 to 20 because I need 20 terms. So from first term, this k is the number of term actually. From 1 to 20 you are going. And what is the variable here? N is the variable. This is the changing, this value you are changing, this n, by changing this value of k. If you put k equal to 1, that means this will be equal to 1. So it will be 3 into 1 minus 2, that is 1. If you put 2, then it will be 4. So this summation is nothing but whatever values will come from this series, it will be added 1, 1, 1. So if you put first one, this, then plus, the meaning of this one is plus next term. What will be the next term? If you put 2, then plus next term. So you can see this series is coming. So instead of writing it up to 20 S50, S20, this long way, you can write it using this symbol notation that is known as summation. So one such more examples, suppose I want to sum 1 plus 2 square plus 3 square up to 100 square. So I can write it in this way, summation k equal to 1 to 100 k square. So this summation will take care of summing each and every term, putting first k equal to 1, then it will put plus, then it will put k equal to 2, then it will again put plus, then it will again put 3, then it will again plus. So one term you get, then you put plus. Next you put second term, second value of k, you get the second term, then plus third term. So it will be a continuous series. So some properties you can see of summation. If there are two different items, that is both are variable, suppose it is k square plus k cube, so you can separate it, summation k square plus summation k cube. This can go separate because plus minus in series, it is not mandatory that you have to take plus 1, 2, then 3. You can take these two plus this, you can add later on. So first I am adding all k square. Suppose it is k square, summation k square plus summation. Suppose it was summation k square plus k cube. So you can separate it, summation k square plus summation k cube. Because what is the meaning of this one? This first term meaning is 1 square plus 1 cube plus 2 square plus 2 cube. So what you can do, you can make these two 1 square plus 2 square, and you can dot dot dot, and you can take 1 cube plus 3 cube, all cubes together. No issue. These will give same thing, because ultimately we are adding all this. So that's why you can segregate these two, plus or minus, even in minus also. Now something scalar, here the variable is r, k is something scalar which is constant value, it is multiplied with each term. So if it is in there in each term, suppose this term is multiplied with 3, so you can take 3 common. So that's why I am taking 3 common, then summation of this series. So you can take k outside of your summation because k is not a variable. Variable is r here because you are changing the values of r. Now another applications of this sigma, this you might have seen in while we are dealing quadratic equations. In one examples of advanced I have taken this way. Suppose they have asked you to take the summation of roots. You know there are roots alpha, beta, gamma. So if I say summation alpha means how many different types of alphas are there. So in cubic expression there was 3 roots. So if it was alpha, beta, gamma. Summation alpha, beta or summation AB means suppose you have ABC 3 variables. So if I say AB means how many 2 types you can take, AB, BC, CA. So this is. So suppose you have a summation which is a cyclic pattern. That is, you can see it is a cyclic ABC, BCA, CAB. It is just changing the positions. The rest is remains same. So you can find a cyclic nature here. It is cycling. It is just cycling out, and then again it's coming back to its original position. So whatever possible you can write it ABC. You can keep A square here, you can keep B square here, you can keep C square. There are 3 possible, so all 3 you have taken sum. So that we can write it in this way without giving any symbol here, any variable k is 1, 2, 3, no. If you write it in this way, that means in whatever possible way you can write ABC in this fashion, that possible ways will be added together. So there are 3 ways only you can write it, either A square here or B square here or C square here. So you add all these 3, that is the meaning of this one. This same thing is this one. So if here you can say, suppose ABC are 3 items they give and they tell you that summation AB. What is the meaning of this one? In how many ways you can write 2 together? So it is AB plus BC plus C. This is the meaning of this one. If they say summation A square, in how many ways you can write using this 3? A square, same thing you can write with B, same thing you can write with C. So this is also another beautiful use of this one sigma. We have used it in quadratic equation, you can see. Now this series you have to remember, you can prove it, but I am not going to prove. The first one is very easy because it is AP, so you can use the sum of AP. Here you can use A plus B whole cube, A plus B to the power 4, but it is not required, you can do it, remember it. So K is 1 to 2, if you add n natural numbers, then it is always n into n plus 1 by 2. We have used this one and I told you while using this one, I told you it coming from an AP, you will know it later. So this is very important, you remember this one. Summation of all squares of natural numbers from 1 to n square, it is n into n plus 1 into 2n plus 1 by 6. Summation of all natural numbers n cube, 1 cube, 2 cube, 3 cube, it is n into n plus 1 by 2 whole square. Now we can see there is a beautiful relation between these two. Summation k cube is nothing but summation k whole square. Even it is cube, but it is this whole square. You can see this is a very peculiar thing. Suppose you add 1 cube plus 2 cube plus 3 cube, it is nothing but you add 1 plus 2 plus 3, then take square, it will be same. So this is the meaning of this one. You individually cube then add, which will be nothing but individually sum then square. So very important observations is there, so you can remember this one. If you like the video, then press the like button and please give your valuable comments in the comment section.